Good morning, everybody, and thanks for joining us today. My name is Sean Lucas, and I'm the Director of Solutions Engineering here at Ruckus, and longtime field solutions engineer for Ruckus as well. One of the things I've done a lot of here at Ruckus is design and implement RF networks. Some of you on this call probably work with me in that capacity. So along the line, I learned some lessons, and one of those lessons that I learned was the importance of solution partnering here at Ruckus. Solution partnering gives us the ability to add value and capability to networks and sold by you guys who are our value-added resellers. Some of those partners are partners like Ekahau, RGNets, Purple Wi-Fi, Siemens, Bradford, Philips Lighting, but they all help us create solutions that are unique and give you the ability to deliver additional capabilities to your customers around the globe. Ekahau is a particularly special partner in that they create RF tools for planning, design, and implementation of wireless networks. For us, that's a big deal because those are really big pieces, right? I mean, when you go out and you do an installation, a lot of times you go out, you eyeball it, you put up an AP, maybe your competitors, the other resellers out there are doing one per classroom, or maybe I'll put one here, one there, maybe I'll put a better access point here. But the reality is you don't know what it looks like. RF is invisible. So Ekahau brings a physical element of visibility to RF, and it does it with its planning, design, and implementation tools. So when I was growing up, my dad was a contractor. He built things with his hands, and one of the things I always loved about my dad is he could look at a pile of wood, he could look at a pile of metal, and he saw a building, he saw a roof, he saw a use for that stuff. In RF, we can't see it, right? We can't be those great craftsmen, but we can be like my dad and use great tools, right? So 3 things that you use a great tool like Ekahau for. The first of which is something we call predictive analysis. The second of which is site survey. And the last piece is post-installation validation. Now those 3 things go together. They're peanut butter and jelly. And here's why. So predictive analysis is where you take a scale drawing of your customer's facility, and it provides you with an estimation of wireless coverage and capacity based on the attenuating factors of walls and other materials. So when I say attenuating, what attenuating means is if I have let's say a 10-inch thick concrete block wall, there's going to be some factors built into Ekahau that are going to tell me what the attenuation value is or how much it affects your wireless propagation through that surface. So when I build that scale drawing out, I tell it what all those walls are made of, and then I can dynamically drop access points, it will give me an idea based on the information I gave it of what the Wi-Fi coverage and capacity is going to look like. Now, because I told it what the walls are, because I told it what the building is made out of, because I told it where the walls are, it's only as good as the information that you put in. So we call that garbage in, garbage out, right? And that's why the next piece is so important. So that predictive analysis, I kind of have an idea now. I kind of have an idea where my EPs are going to go. A lot of times in our business, we see people just go right ahead and place a bomb and place an order based on that prediction. But then you get out on site and you find out things are very different. Maybe the walls are thicker. Maybe the walls are thinner. Maybe the floors are composed of something different than you thought they were. And that's why it's so important before you place that bomb to go out and do the site survey. Now, the site survey allows you to take that same scale drawing or even that same predictive analysis and go out and test against that prediction to make sure that what you thought that wall was made of, what that attenuation value of that wall is exactly what you thought it was. It takes that 70% science of predictive analysis and makes it a 90-95% science. So instead of guessing, we're doing on-site evaluation. Now I'll give you guys a great example before I move on of how I did this and used this exact product, Ekahau Site Survey Pro, as a sales tool. So I went down to a nursing home. It was in Richmond, Virginia. They had 18 nursing homes they were evaluating RF for. They had a hallway that had 5 access points in them from a competitor of ours that I will say rhymes with Crisco. But they said, you know, we were interested in getting an idea of what Ruckus will cost us. I said, well, I'll do you one better. I brought a few access points with me. Let me do a survey of this hallway for you, and let's see what your Wi-Fi looks like in this hallway. So we did. We did a predictive analysis survey. A little different, but we're using it as a sales tool. So I took that and I walked down and I gave them a report and I said, here's what your Wi-Fi coverage looks like. Here's what your Wi-Fi capacity looks like. Here's where your dead spots are. Isn't Ekahau awesome? Let me do something else for you. I'm going to take those 5 Crisco access points down and I'm going to put up these 3 Ruckus access points. That's right. I'm only going to put up 3 and I'm going to go do the exact same report. And I did the exact same thing. I walked down that hallway. I came back. I gave them another report. I pushed the 2 reports across the desk and I said, here is a visible representation of the differences. The customer looked down at the reports, flipped through the pages, looked up at me and said, where do I sign? Ekahau paid for itself in 2 hours. That's the beauty of site survey in addition to predictive analysis as a sales tool. The last thing that I use Ekahau for before I turn things over to my friends Jerry and Jussi is post-installation validation. Post-installation validation is one of the most valuable things you can do for your customers because every time a customer has a problem, and I know you guys have all heard this out there, I know you're going to tell me when you chime in the chat, you're going to tell me that everybody, every time they have a problem, they tell you the Wi-Fi is down. They tell you the Wi-Fi is broken, and it's almost never the Wi-Fi, right? It's DNS, it's DHCP, it's a firewall problem. These things always come up, but when they really come up is right after you do an install. But if you do a post-installation validation, where you go around and you do a second site survey after your installation, where you show them, again, coverage areas, capacity, areas of density, areas of interference, potential areas where they may have a problem based on a design consideration. Maybe it was cost considerations. Maybe they had an elevator shaft. There could be any number of reasons why. Maybe there's an underserved area. Any of these things that you can show them in writing after the fact. Number 1, that here are your issues. Here's where everything's great. And number 3, here's where I did exactly what I said I was going to do. We delivered on excellent Wi-Fi. We promised you excellent Wi-Fi, and now we proved it. So now when they think they have a problem, big chance they're not going to call you and tell you it's a problem with the Wi-Fi because you gave it to them in writing and showed them where it worked. They'll look elsewhere. So it's going to reduce support calls for you. So Ekahau gives you the ability to predict a network, draw it. It gives you the ability to use it as a sales tool and lower your site survey times, because when you have a predictive analysis, you're actually surveying to the prediction as opposed to just walking around guessing. And the last piece is that post-installation validation that gives you the ability to go out there and prove that you did what you said you were going to do. There's no other product in the business that does it as well. This is my personal opinion. I'm a big fan of Ekahau, and I'm really glad they joined us here today. They're going to tell you about this product. Again, this is a product that I personally use. This is a product that I will personally pay for, even as an employee of Brocade, because it's that good. So my friends Jerry and Jussi are here to tell you about it. I'm going to let them take over. Thank you very much for your time, and I look forward to helping you guys with any of these considerations moving forward. Jerry and Jussi, take it away.
Thanks for the very warm and excellent introduction. So I've got Jussi here with me as well. Jussi, want to intro yourself?
Hey guys, thank you for coming on board. I'm Jussi. I do all kinds of janitorial duties here at Ekahau. Here to help out Jerry, his right-hand man.
I appreciate the backup and support that you provide for me, Jussi. No, it's
anytime, man.
It's a great environment we have here for sure. So yeah, I think we've got a great kind of presentation set up for you guys here. We're going to be talking about Wi-Fi network design. As Sean kind of already hit on a lot of those, what those complexities are. We're going to talk about how we can utilize the Ekahau Site Survey tool to provide you visibility. Kind of think of putting on those Wi-Fi glasses, right? So being able to see the Wi-Fi, see the signals from a predictive standpoint, but also from a validation and an actual real-world RF measurement standpoint to see the results. So yeah, let's maybe kick things off there, Jussi, and you've got a few slides we can run through, and then we'll dive into doing some live demos.
Sounds good to me. We'll do some quick death by PowerPoint here first, and then we'll move into the deep, which is the demo. But just a few slides about Wi-Fi design, kind of what's essential when it comes to Wi-Fi design, and just to set the floor for Jerry here. So one question, if you don't mind punching in on the WebEx Q&A board or the chat board. Jerry has it open here actually. Which Wi-Fi planning tools, if any, are you using today? So Wi-Fi planning or site survey tools, what kind of tools are you currently on? If you could please answer on the WebEx chat board or the Q&A board, we could get kind of an understanding on what kind of an audience we're talking to here so we can better target this. And maybe you can, if you want, you can share a couple of words about how you design networks today. If you're not using any tools, that's, great as well. Okay, so we're starting to see responses, air magnets, anything else? Anybody else use any tools? MetaGeek, EDX. All right, very good. Anybody else using any Wi-Fi networks, site survey or planning tools or troubleshooting tools, analysis tools, stuff like that? That's already good. We were mentioned air magnet, MetaGeek, EDX, air magnet, but have used Ekahub before, Zone Planner, which is air magnet. Cool. Very good, very good. So we do have a lot of tool users here already. So definitely that's good to know. All right. So the whole idea of the Wi-Fi design is really, isn't it to design like sound Wi-Fi that really works? And here's just a couple of examples on when things go south. What do you think of this? What's again, maybe on the QA chat board, wherever, what's wrong with this installation here? And the correct answer is not that it's an Aruba AP. So what do you think, Jerry? What went south here?
Well, I think it's obvious, right? The metal pipes are used to further broadcast that signal, right? To amplify the signal. Isn't that how it works? You
Exactly.
Put a couple metal pipes in front of your APs to carry the signal through the building?
Exactly. The metal pipes act as additional antennas, right? No, obviously, yeah, the metal pipes are kind of, hurting the signal a little bit. So please don't place APs above the metal pipes as shown in these two pictures. And I believe, what do you have to say about this picture, Jerry?
Yeah, that picture is bringing back some memories. I think I recall actually taking that picture myself. That was actually in a hospital, if I recall correctly. And what's not too obvious in that picture is if you look at the very bottom corner of the picture, you can start to see a little bit of a fluorescent light fixture. So not only is the EP kind of positioned and kind of resting on top of a few metal pipes, directly underneath that access point is actually a full metal light fixture.
Nice.
Yeah. Nice. So, again, really using that metal to help carry the signal for you.
Exactly. And what about this one? This guy here, also a metal shelf, but it's vertically mounted. So is that better?
Well, that's maybe a new way of security, to really hide those APs so that nobody's going to steal your access points. Maybe I'm not sure what the design process was behind that one.
Hidden SSID, and then there's all kinds of creative antenna placement for the APs. So let's try to stay away from these ones. What about this one here?
That's a new best practice maybe for mounting APs. A more sleek mounting idea there. I'm not too sure on that one.
Yeah, it's nice and white, man. And then there's this one. All the radiation coming out of Wi-Fi. This quite nicely blocks that.
Yeah. That's one way to fix a co-channel interference problem, right? Too much signal. I guess you can contain it that way.
Exactly. Anyway, so that's the idea. And last but not least, the high capacity, high density design.
The Xavier Wi-Fi. That's what it was. Dr. Xavier's looks like reminds me of his wheelchair with the X's on it.
Exactly. Yeah. Anyways, so on with the show. So just so that it's easy to understand the Wi-Fi and also explain it to a customer, this is what I usually use. Like setting up a Wi-Fi network is often like setting up a bar. And the reason I say this is it's not because I like to drink, which I do. Hello. No, I'm kidding. But the reason I say this is because, setting up a Wi-Fi is kind of like setting up a bar, because just like the Wi-Fi network, the bar also consists of, in a bar you have bartenders, in a Wi-Fi network you have APs. And in a bar you have clients, in a Wi-Fi network, obviously you have client devices. And what is the goal of a bartender, Jerry?
Well, you got to get the beverage to the client, right?
Exactly. You've got to get the wine from the bottle to the glass. And similarly with Wi-Fi, you've got to get those bits transmitted between the AP and the client, right?
And they need to do it efficiently, right? They got to get those orders in and get the drinks out to the users as quickly as possible to free them up.
Exactly. And that's why you cannot like have a total chaos behind the, bartenders or in the bartender's area in a bar, right? Otherwise, it wouldn't be very efficient. And same stuff with Wi-Fi. Just to set the stage here, this is pretty easy when it comes to a bar and when it comes to Wi-Fi as well. So if it's not high capacity, like in your home, for example, it's not very high capacity. It's one or two routers, a few client devices. This is not high capacity now, is it?
This is, you're going to Best Buy and picking up a consumer router access point and putting it in and serving up a couple of clients, right?
Exactly. So that's what we would call, Jerry,
what is it? The icing on the cake?
that was your guess. Yes.
That was my late night, quick thinking off the bat.
Yeah. Exactly. So it's a piece of cake to do non-high density Wi-Fi. You just put up enough APs and there you go. Wi-Fi protocol or 802.11 protocol is pretty resilient. So low density, just fill it with APs and there you go. However, this is what we're talking about. So this is what kind of needs a bit more careful design. So I'm sure no one has ever seen any problematic Wi-Fi networks, but theoretically, if there were some problematic Wi-Fi network somewhere, it's usually because of this. It's because, more and more APs, more and more client devices, and more demand for data. Not such a simple scenario anymore now, is it? You need to be, a bit more organized in terms of how to set it up.
Well, I'm thinking back just to the previous slide of the one-to-one, right, where we had, talked about going to Best Buy, picking up some consumer gear. I mean, just think if we try to apply that same practice in this environment, obviously this is going to be just, falling its knees there of just being able to try and handle that type of load with a single access point or, just from a infrastructure standpoint, we need all this to be working very seamlessly and have that kind of harmony behind the scenes to be able to handle all this and be able to know how to optimize for this environment.
Exactly. And that's why we really do, we do tools and education for people who design high quality Wi-Fi networks. And just to, limit the scope of the presentation a little bit, we do not consider Wi-Fi or fixed networks at all. So this will be outside the scope of this presentation. And this is pretty straightforward stuff from a Wi-Fi guy's perspective. So it either works or doesn't. The pipe's either there or not.
Yeah, see, we don't even need to talk about wired. It's, it's that simple, right? It's straight from the tap and, wired is easy, right?
Of course, having that said, you need a pretty big pipe for things to work, and of course you need a sufficient cable and stuff like that.
There's lots of considerations on the wired side, but from an RF standpoint, a lot of other variables to consider, right?
Exactly. So what we're trying to say is pay attention to your Wi-Fi design, and because this is the approach we see typically people taking. They pay hardly any attention to the Wi-Fi design, and kind of people hardly bother to ask the customers what they're looking for or design the network or validate the network. But then it results in us being this guy in the green shirt listening to endless yelling of the Wi-Fi doesn't work. Which Sean, thank you, my friend. That was an excellent intro. So Sean was referring to this exact situation as well. So this is kind of what we're trying to root for is a more sound design approach where you spend a bit more time asking the actual customer what they want and designing accordingly. That results in us, to be more in the chilling mode later on. So I guess the question is, which guy do you want to be?
That's a tough one. I don't know.
Yeah, I do like talking to people.
I like that green shirt. I think I'm gonna go to the green shirt side. I'm not a big fan of the yellowish shirt. I'm not sure what's going on there.
I didn't even see there's a difference in color. I'm colorblind, obviously. Anyways, so just some of the basics. So if you're too far away from the AP, just like you're too far away from the bar counter, you'll have low signal strength. So that's a given. That's something you need to have. So go close to the bartender. you'll get high signal strength, and of course the clients need to be able to authenticate to the network associated to the network. Right. Fair enough. But here's the beef when it comes to like how Wi-Fi works. A bartender in a bar serves just one customer at a time. And the same is actually true with Wi-Fi. Although Wi-Fi seems like fast, and I have 58 clients connected to the AP, and it's still very fast. Actually, only one of those client devices is being served at any given time on any given channel. So, and that goes a bit more extended from there. If you have two APs operating on the same channel in the same nearby location, even still only one client is being served at any given time. So in this scenario, like adding more APs doesn't always help unless you utilize your channels properly as well.
Right. So yeah, how can we, I see bars all the time loaded up with people and, maybe only one or two bartenders behind the counter. How can that be? How can we have, 20 different people all at the bar and only have one or two bartenders serving up all those clients?
Yeah, exactly. So that's kind of why the transaction time in the bar is vital, and that's why with Wi-Fi, high data rates are vital. And data rates really are made up of a couple of things. So you need high signal strength, and you need low noise levels, or at least the signal needs to be much higher than the noise floor. And we talk about SNR, or signal to noise ratio. And here are some of the things you want to stay away from, both when it comes to bars, if you're over the age of 30, such as high noise. If you're younger, then you can tolerate that. And same with Wi-Fi. So you try to steer away or eliminate the sources of noise, channel interference, and then low client, and why not low AP capabilities as well? If you have old APs, if you have old laptops or barcode scanners, those will be hurting your Wi-Fi quite a bit.
Yeah, a lot of things to contend with, right? So a lot of things that we need to consider besides just our own network, but neighboring networks, but quite often our own, on the channel interference side, we're our own worst enemy is really what that kind of is indicating there is, we're contending with ourselves, our own APs. But then there's also other considerations there as well.
Absolutely. So just to wrap things up before the demo, what have we learned so far? So we learned that, here's actually a question for the audience. Why is this guy unhappy? And the first one to answer in the Q&A board or the chat board gets the hoodie. So why is this guy here unhappy? Eka hoodie to the person answering correctly.
Not getting service.
Yeah, there you go. So Najit, feel free to email us, me or Jerry at ekahau.com or Jussi at ekahau.com, and we'll send you a hoodie. So he's definitely not getting service, and PRA is also right. Bartender not hearing him. So that's exactly right. So this guy is suffering from. Whereas the women at the close to the bartender, they're getting great high data rates. These people here are creating some high noise levels, so this guy is suffering from low signal strength as well as very low SNR.
And what would we see in the real world with the Wi-Fi world with that guy trying to get his order in? What would we measure that as?
What would we measure that as? Low signal strength.
But what would that result in? How many times does he need to get his order?
Yeah, exactly. High retry rate.
Retries. Yeah, he's not going to get his order in on the first try. So it's consuming a lot of airtime to have to put in his order multiple times just to get his request in. And might see the same thing from the bartender side, right down to the client. Have to retry that transmission multiple times to get that drink to the end person. Yeah.
Exactly, and at the first try, the guy might be speaking pretty quickly, trying to get the order, and then it fails, and then he might, speak a bit more slowly, consuming everybody's time. The order still doesn't go through. So yeah.
I like this one here. Put hands around his mouth and shout. What would that be in the Wi-Fi world?
Directional antenna, right?
Yeah, or the beam technology.
Exactly. Beam forming.
That's great. Yeah, great tie in there, Pierre.
Exactly. And of course, you don't want to let these guys in your bar either. So to make everything more efficient, the low performance clients should be shut down. And talk about client device efficiency. If most of the clients are 3-stream clients, then you'll be 3 times faster in terms of data transmission, which helps a lot as well. And this could be considered as EMEA MIMO, so serving multiple clients at a time. But here's the deal, though, with Wi-Fi, as we talked. So adding more bartenders doesn't always help. If you have clumsy, slow bartenders, adding those will actually hurt the network. Same with Wi-Fi. If you have if you keep adding Wi-Fi IPs, at some point you will overload the network and it will start actually hurting and not helping. But if you do smart channel planning on 5 gigahertz in high density, use narrow channels, so not those 80 or 160 megahertz, but rather 20 megahertz channels. Smart channel planning, smart Wi-Fi design.
Wait, you see that those 5 gigahertz bartenders can only service much smaller areas. Wouldn't that be a negative thing?
Yeah, but isn't that actually what we want, right?
Yeah, it's almost counterintuitive, right? So we think, we can only cover so much area with this 5 gigahertz, so it's worse, right? But it's actually the opposite. Because it covers a smaller area and we can contain those cells, we can reuse that spectrum, and it provides a much cleaner RF environment because we don't get all the bleed through from neighboring networks from multiple floors above or below or next door that we have to contend with. So it reduces that contention as well.
Exactly. Less interference from the other bartenders, less interference from the other customers.
Right.
And then you want to avoid things like hallway placement if you can. Not you always, of course, can't, but if you can, put the APs in the rooms to avoid code channel interference. Here's kind of to summarize the whole thing. So more APs is not always better because it results in code channel interference.
I didn't know Batman was so into Wi-Fi.
Yeah, dude. These modern times, right? And finally, before we go to the demo, so here's an argument you hear quite a lot. That planning or site survey just slows down the sales process. So I can't justify that to my customer, or I can't do it because it just slows things down. Well, not sure of that. First of all, you can charge more for those services if you sell them well. And here's the trick. So ask your customer, what did he want? Like this is the kind of bar you wanted to set up. But if you don't design it properly, if you don't validate it properly, this is the kind of bar you're going to get.
A little different.
Yeah. So the question is, which one do you want? Do you want to be sure that you're getting the former, or are you risking things and maybe getting something like this when you sign up the network? So that's all there's to it.
Got to validate, right?
Yeah, you got to validate. And to validate, even before validating, in today's Wi-Fi networks, they're not solely built on coverage, right? Wi-Fi was built in a few stages. First, we started on these meeting room designs back in the early 2000s, where we just put in access points to cover the meeting rooms mostly, because that's where people wanted to utilize Wi-Fi. They had cables to their desks.
Yeah, right? We call that more the portable Wi-Fi, right? I can take my laptop from my wired connection at my desk, and I can go into a conference room and use the Wi-Fi in the conference room, but it's not a mobile network, right, where I can't seamlessly go from my desk, wirelessly to the conference room.
Exactly, and then became this pervasive coverage or ubiquitous coverage, right? Where the whole building was quote unquote covered with Wi-Fi, blanketed with Wi-Fi, and that's when coverage was the king, and that was let's say between 2005 and 10. Yeah. That's all that was needed, because not a lot of devices, smartphones and tablets only had started to happen, things like that.
And still the focus with that was, how can we cover this building wall to wall with as few of access points as possible, right? Just to say that we have Wi-Fi everywhere, not necessarily good Wi-Fi or not anything for a significant number of users, but at least that you can connect to the network anywhere in the building.
Exactly. And from there, like let's say 2010 and forward, we started focusing more on the capacity-based design. So smartphones, iPads, and 802.11n standard kind of enabling all that. So we started seeing that, okay, I get bars, but the Wi-Fi is still slow, and that's when we started calculating for capacity. And of course, today with video and all that, it's more important than ever. And when it comes to calculating capacity, Jerry, what are the key factors for that?
Well, there's quite a few considerations. I'm curious to see in the Q&A if anybody has any ideas for calculating capacity. First and foremost, I'm going to throw out we need to know the number of users, right? So how many users are going to be accessing the network? But what are some of the other considerations from a design standpoint that we need to know besides just the number of clients that are going to be accessing the network? Checking the Q&A board here, see if anybody has any other considerations that we want to factor into that calculating capacity metric. How much data from each? Very good. Yeah. So
exactly.
What are the clients doing on the network, right? What applications are they running? What is the SLA? What is the requirement those clients need from a data rate standpoint and then airtime? From a is it okay if the network's going fast, slow, or does it need to be running at a consistent speed to support things like voice over Wi-Fi or latency-sensitive applications?
Exactly, and the types of clients as well.
Yep.
Things
Mobile,
like that.
laptop, very good.
And then the distribution of clients, like where are the clients located? And yeah, just like said there very well, are the customers drinking beer, wine, or shots? So what kind of applications are they running? So all this needs to be factored in. And this actually is a pretty good lead into our demo. So Jerry, would you mind, with all this said, and there's your checklist for good quality Wi-Fi anyway. Feel free to take a screen grab if you want. So passing the ball to you, Jerry.
All right. So get Ekahau pulled up here.
Make presenter, Jerry Alla. Yes, I'm taking a big risk making you the presenter.
All right, I'll try not to let you down.
Try to behave, man.
All right. All right, so I've got Ekahau pulled up here, and this is the...
Is that running Windows or?
This happens to be Mac, but we are, we're an open company, right? So we support both the Windows and Mac platforms, or I guess we will be supporting the Mac platform soon. This is a beta release that we have currently available to the public. So if you are prefer the Mac platform, you're welcome to check that out. But yeah, it works in both Windows and Mac. So I'm running the native Mac version here, the beta. And let's go ahead and, let's just run through a quick predictive design with some of the stuff that we just went through in the slideshow here. So first thing first, is adding a floor plan, right? So I'm going to go ahead and pull in a floor plan. And when it comes to floor plans, we support a pretty wide variety of file formats. So I'm going to open up a DWG, which is, obviously a more complex file format, but I want to show you some of the additional advantages that provides by providing, these computer drawings, so we can extrapolate some additional information out of these floor plans that we can use to our advantage from an automating kind of the tedious work of RF planning. So one of the first things I always like to do, you can see the floor plan here, is since this is a CAD file, sometimes the architect sets up multiple layout views. Now, I'm not an AutoCAD person. I don't have AutoCAD installed on my machine. I wouldn't know what to do with it if I had it, but you can see from a UI standpoint here within Ekahau, we make it very intuitive, just being able to select different elements and pretty easily, understand how this CAD file is set up and be able to extrapolate the specific pieces of this file or this floor plan that are going to be useful to our needs here. Let's go through a couple of the layers here. Now on the left side, I'm going to choose the first layer here as the A door layer, which is going to highlight all the doors contained within the floor plan. Let's go ahead and apply some different attenuation to the floor plan. One of the options that we have is also cleaning up the floor plan as we bring it in, being that it's a CAD file with layers. I can toggle off the layers. That's what these checkboxes here show. Let's click on a couple other layers here, like the stairs. We could apply maybe that cinder block stairwells there. Then we have some exterior glass on the building. I'm going to apply that here. You can see there's a kind of set database here that I can work with of materials, but this is completely user customizable. So you can see we've already pre-populated these materials with the most common kind of materials from an RF planning standpoint that you're going to need, but there's going to be use cases we know out there, so we allow you to customize that. Well, there we can see that's pretty well defined. All my layers there are highlighted that I'm applying attenuation. Just for fun here, I'm going to clean this up a little bit. I'm going to turn off the room numbers. Typically, I would keep those on, but I just want to show how we can turn off certain layers as well. So you can see I've unchecked that box now, kind of cleaned up the map a little bit.
So that's turning off only from the background map, right? Exactly. So it has no effect on the attenuation. It's just, you can, if it's a cluttered drawing, you can turn stuff off from the background map.
Yeah, just from a visibility standpoint, sometimes you get these CAD files that have, hundreds of layers. It might have the lighting system, the fire suppression system, the security system, all these other systems throughout the building that we don't necessarily care about from an RF planning standpoint. So we can toggle those off quickly or just import the specific layers that we care about would be the other approach.
Very good. And there we have the plan. So we didn't have to draw manually any walls, did we?
We didn't, no. And if I wanted to do any tweaking to the, the way the automatic wall detection pulled in some of these walls, I could quickly make those edits and those changes. But yeah, let's take a look at a couple of things here real quick before I place an AP on here. One of the things that's really nice is there's some intelligence that it does use when it's pulling in these layers. So it's not just tracing the lines like you'd think. There's actually some engineering here that's happening. So, for example, if you remember when I selected the door layers, the doors are all indicated as an open door on the map. However, from an RF planning standpoint, it's going to be much more optimal to have that door closed, to represent that, closed door signal, the effects on the signal propagation. So here you can see that's what's happened. The door is still indicated as an open door on the map. However, the attenuation layer is actually drawn in as a closed door, which is, helpful for our planning purposes.
Nice. And I see the wall layers also, often in CAD drawings you see that a wall consists of several lines, as we can see here as well. But so it seems to kind of simplify the wall lines as well. Is that fair to say?
Yes, yeah, and it did a pretty good job of it. Like I said, this one has some, some interesting things on the map, so it's not going to be picture perfect every time. But, again, to your initial point there, the focus here is obviously saving a lot of time and being able to automate that tedious task that's typically associated with RF planning.
Sweet. And you can go back and edit the wall materials later, right? So if you saw that all of your drywalls were 2 dB and not 3 dB, you can go and adjust those. And it's fully 3D, right? So you can even go height of the walls, height of the attenuation areas, and do multi-floor really, really easily, things like that.
Yeah, very quickly. And, that's one of the things that, I really appreciated at Ekahau prior to working for Ekahau as a customer was the intuitiveness of the software, but also just the flexibility, right, and the customizability that we give the engineer that's using the tool. So you can use the defaults as a great starting point, but then you can fine-tune things as you go along. So it's really built to be that iterative process of starting as potentially like a sales tool to quickly just get a rough idea of how many APs and still accurate, and then when you're getting into the actual deployment part of the process, refining that further before actually maybe ordering the equipment or at least before running the cables and installing that. So you can use the tool through the entire process, the entire life cycle of the Wi-Fi deployment.
Sweet.
So yeah, let's go ahead and place an AP on here. We have over 1,500 different access points in the database, so I'm going to filter down to just showing the Ruckus APs in our list here. Let's simulate one of these access points here. Let's grab, I like the R710 is a great one. You can see we also have some like the T710s here. So let's grab the R710, and I'm just going to place one in the middle of the map here just so we can get an idea of how we can simulate this RF propagation from like a single access point, and then we can look at some of the things that we can do to alter that and change that. There's my signal output. You can see the heat map. I've got mine configured, and again, we have the customizability. I've got mine customized to show the signal closest to the AP as the hot signal, the red, and then as you move further away from the access point, it turns into essentially a blue and then goes gray. And the gray is indicating that the requirements for our project are not being met. And right now we're applying just a basic voice plus data requirement as kind of a default. And you can see here my requirement for a good voice and data network is going to be -67. And that requirement in this where I have my mouse is not going to be met based on those wall parameters and things like that that we've input into the planning already.
Very cool. So we mentioned this coverage design and capacity design. So you know, you could, based on, because the Ruckus APIs provide awesome coverage, right? So theoretically, you could just place a few of those and be done with the plan, right?
Yeah, I mean, you can see here from a coverage standpoint, it really would take very few access points if I don't need to be concerned with, you know, with coverage, or I mean, with capacity. You know, if I'm only concerned with, you know, painting the walls green, if you will, or in this case, kind of a red, as I've chosen the hot to cold scheme.
That's a good color.
You don't like my colors?
Reminds me of an older tool from different vendor. Anyways,
hey, easy enough. I can swap my my colors back to the default with a click of a button. Does that make you happy now?
Oh yeah.
Easy enough to switch things. So yeah, you can see I've pretty well covered this building wall to wall with signal with as few as 5 APs, right? So if I really just cared about signal and that was it, you know, we could probably provide good capacity. I mean, good coverage in this building without, you know, factoring in capacity. But let's see what happens if we factor in some of those other criteria like capacity, and we'll say this is actually a university. And we've got some lecture halls and things like that that are going to need, you know, quite a few users piled into, you know, some smaller areas of the building. The first thing I'm going to do is define just a big, pretty much box around the map, because we're going to need coverage everywhere inside the building, like we mentioned. But then we can define some specific areas that are going to need some special requirements, right? So some special consideration from our planning. So we're going to plan for high capacity then within that coverage area. So I've defined my main area here. You can see area 1 is defined. I can go and tweak those parameters if I wanted. We'll just say this is our main coverage area for namesake here. And then we'll also, you know, we can also tweak any other parameters here of the coverage profile and then add the number of devices. So let's say just in our general coverage area here, we need to account for 200 devices. We're going to have 200 laptops in that area. So we'll start with that, and then we'll work from there. So I'm going to also plug in these areas here, kind of in the middle of our building, are actually some lecture halls. There's quite a few seating areas in here that we need to support or plan for and account for a few hundred users just in that section of the building alone. So again, back to our slide, you know, we talked about for capacity planning, needing to know where our users are, right? Not just the number of users, but where are those users in the building. So let's say we're also going to have 200 devices just in this section of the building. And we can go into the you know, area here that we created, and we can call those our lecture halls. And then you can see here the coverage profile. We could change that if we needed to. We'll keep those as voice and data for now. And we can you know, tweak any other parameters here. You can see it's already divided up for me, split these into laptops and smartphones. I think that's a good starting point for the demo. And you know, you can tweak that as we go along. But let's use that as our starting point. And let's go ahead and run what we call our auto planner. And that's going to suggest those AP locations and the quantity of AP based on some parameters here. So at the top, we're specifying those 2 coverage areas we've defined, our main coverage area as well as our lecture halls, and factoring the device counts for each of those areas individually. Then we're going to plan for that R710. We can tweak any advanced parameters here in the sections below. Uncheck the box here. You can see we have quite a few options.
And we provide reasonable defaults, right, for sound Wi-Fi network design, like, you know, 2.4 gigahertz. You probably want to use a lower transmit power in most cases than 5 gigahertz to get, you know, because 5 gigahertz has more capacity. We want more clients to associate there, and the tool accounts for all of that.
Yeah, kind of a natural band steering, if you will, right, to kind of help those clients make better decisions of preferring the 5 gigahertz over the 2.
How's this for a term? Organic band steering.
Nice, organic. I like it. Everything's going organic these days, right?
Exactly.
That is a hot term in the industry.
Organic is how you like your eggs and your band steering.
I like my organic Wi-Fi. I like it. All right. So yes, here we can adjust all the other, more detailed parameters. But like I said, from kind of thinking of this as starting with maybe a rough predictive design, we can typically stick with the default, and we know we're going to come up with a pretty optimal to configuration and planning. So let's go ahead and see with just the default parameters without tweaking any of these knobs, how it does from an RF planning standpoint, and see beyond just planning for coverage, if we're planning including capacity into a plan, how does that change the design, right? Change the number of APs that's going to provide good Wi-Fi in this environment. So here, if I bring my column back over, we can see the actual simulated access points. Well, we went from 5 APs for just providing coverage in this building to now factoring in capacity, taking us up to 14 access points.
Now, Jerry, as a systems integrator or MSP, does that mean I can sell more APs with this tool?
Well, you can now have the ammo to back up that, right? So this is the nice part about this is with the tool, we can generate these reports and visualizations to say, hey, I'm not just pulling this number out of thin air and trying to sell you more APs. This is the design requirements. And the beauty is you could show them even 2 different designs, and you could say, or maybe 3, kind of do the good, better, best approach and say, hey, if you just want coverage, yeah, we can install this with 5 APs, but if you want to meet these criteria that you provided me, these requirements for capacity and, optimizing it for a good Wi-Fi network, and this is the appropriate number of APs and how we're going to meet those specifications.
So let's take a look at the plan. So it seems like the tool actually did place more APs near the high capacity area.
It did, yes.
So that's pretty smart.
It's like some inside, but then you also notice it also surrounded those areas, so it's getting good separation with those cells is kind of the focus there.
Nice. And what do we have here, right below the area?
Well, that must be a defect. Why would it turn off a radio?
Yeah, exactly. So what is this? So can you tell us what happened here? So it's turned off a 2.4 gigahertz radio.
That's right. So that's actually a new feature that was added in the Echo Site Survey 9.0 release. As part of the auto planner, it'll actually make suggestions of potentially turning off radios once it sees that we've ran out of airtime on a certain band. So in this case, on the 2.4 band, since we have much more limited spectrum, it's actually saying to meet these capacity needs, we're going to need more 5 gigahertz radios than we are 2.4, and because we have that limited spectrum on 2.4, it'll actually start suggesting turning off certain 2.4 radios to optimize the environment for both bands.
Nice. Minimizes co-channel interference, maximizes performance.
That's right.
Sweet.
Yeah. So yeah, from there we can obviously dive into that further and start to tweak some of those knobs that we looked at. So maybe if we want to look at like airtime utilization, we can see what the environment looks like currently with those default parameters of data rates and number of SSIDs to kind of figure out how much airtime is going to be consumed by the management traffic to maybe see if we can squeeze a little more capacity or performance out of the network.
So what does that red area mean there? So it means probably that more airtime is being utilized than in the green areas because it's part of the high capacity area, right?
Yeah, that's right. So kind of green to red here, good to bad of, how much airtime we're going to anticipate being utilized in different areas based on all those requirements that we've set into the plan so far. So obviously the capacity side of it, knowing the type of devices, the applications those devices are going to be running is going to be able to calculate a very accurate airtime utilization.
And if I just wanted to, like capacity-wise, show a really simple representation for my customer, like, am I meeting your capacity requirements for the devices or not? Because now we have a red area, but it still seems to work. Is there a view that I could use to just show does it work or not for the customer?
Yeah, absolutely. So we can look at it from a few different lenses, but let's look at it, kind of continuing on the capacity planning side of things. Let's look at capacity health to see if there's any issues from a capacity health standpoint. We see that our airtime utilization is getting a bit warm in that one section of the building, but if we look at capacity health, we can see from a AP capability standpoint, we're actually still in pretty good shape here. So we can look at it from 2 different kind of views is, what is the kind of equipment's capabilities, but also from a physics standpoint and an RF standpoint, are we consuming, is there enough airtime, available? Are we running out of oxygen, as a, another way to kind of look at that. Wi-Fi, kind of needs to be able to breathe, right? So it needs that airtime. Even if we have, great equipment, that's very efficient, we still have the physics that are going to apply.
And the nice thing about this is you can also show like how an older, let's say 802.11n network would perform or not perform under load versus how an AC network would just excel. And same thing with your client devices. So if you add in a ton of older client devices in the network, you may show that, this is why your network may be malfunctioning. You have these old 802.11b barcode scanners here or 802.11g barcode scanners here eating up all your airtime versus if we change those to newer ones, there you go.
Yeah.
One of the things today seems to be location tracking, like RTLS over Wi-Fi RTLS. Does this account for that?
Yeah, absolutely. So we can use different parameters. So far we've been just using the default, voice and data for kind of good Wi-Fi. But yeah, we have different options in here from from an auto planner standpoint as well as for validation standpoint of different coverage profiles, right? So we could choose between a bunch of different options here. One of those being location tracking, but you can see a bunch of other options in here as well. Even this nice little Ruckus best practices in here. So maybe that would have been a good one that we could started with, but we could also validate using those parameters as well. So if I go back to using just our current design without rerunning the design, I could do that as well. But just taking the current design, we could validate against different requirements. So again, kind of going back to that method of maybe providing your customers with a good, better, best scenario, you could take a single design and then kind of validate that against different requirements. So we could say against our coverage requirements, and we could change this to instead be something like the Ruckus best practices here, and we could make that our validation requirement. And you can see it will update based on that.
Right. So that's pretty sweet. Mm-hmm. And now we can see if the signal strength meets the Ruckus best practices.
Yeah, and we can see here it's indicating that in my legend here, we're now validating against those Ruckus best practices.
Nice.
So we can, update that on the fly. We don't have to redo our design or anything like that. We can validate against those different requirements, after we've done our design as well.
Okay, and as Wi-Fi professionals, of course, you should always validate the auto planner's plan and kind of modify it accordingly. And for example, if you see a lot of gaps or holes or what have you, you can manually fine-tune the plan, move the access points, add access points, rerun only, let's say, channel optimizer and all this fun stuff.
Absolutely. Yeah, and you can see all these, parameters are able to be, edited as well. It's, we try to give you all the, good stuff to get you started, but yeah, make it fully customizable as well for any use case.
Excellent. So we're a bit low on time, and this is an awesome planner, right? And it's fully 3D, up tilt, down tilt of antenna, stuff like that. But this is just a part of the product, right? So should we spend a minute or two looking at the measurement or site survey, troubleshooting features, and then maybe go to Q&A? We only have a few minutes left.
Sounds good. Yeah. So we've really just scratched the surface, obviously, on the planning side of things, but the other half of the tool is the survey and validation side. So definitely, let's do a quick demo on that. Let me pass the ball back over to you, UC, and I'll have you share your screen on that.
Thank you, sir. All right, and I think I have controls. Try them one more time, or can I do the share?
I'll stop sharing mine.
All right. Here we go. Thank you so much.
Yep. I like to share sometimes,
Sharing is caring. Okay, so once you've made your design, or if you have an existing network that you want to validate, and whether it's your own network or competitor's network or whatever, this is kind of how you go about it. So the tool is not only a planning tool, as you can see here. If I go to the survey tab, I can see some survey buttons here. And as we're doing this, the tool is gathering data from the different sources. So whatever Wi-Fi adapters you throw at the tool, pretty much it can utilize those to your benefit. And you can't quite see the speed at what that we are operating here, but it's doing spectrum analysis because we have a spectrum analyzer connected. It's doing an active testing of the network, so end to end, and it's doing a passive testing, meaning that it's sniffing for all the audible APs around and kind of understanding what's going on in the network in terms of your access points and all the others. And all this data that we see here is being stored when you start, putting the map and start walking around. All this data will be stored on the project file. So I'm just going to open a file where I have performed some surveys. And performing a survey is as easy as just, taking your laptop or tablet, clicking on the survey tool and clicking on the map as you go around. So you click, I'm in this room, you go to that room, you click there, and you wait for a few seconds for the indicator to stop, and then you walk to the next room and click that I'm in the next room now. And again, the indicator appears telling you, please wait as I collect this Wi-Fi data. So that's the kind of easy way to do a site survey, and the end result looks like this. So the tool, when you did your walkthrough, the green lines, the tool was capturing data from all the adapters that are connected, doing active and passive testing and spectrum testing, and the end result is something like this. And of course, the tool can do throughput testing as well. So the tool automatically detects all your APs, places the nearby APs on the map, detects multi-radio, multi-SSID APs, can show all the configurations, and then just like we had before, but now only based on real data, we can show, for example, show me the coverage area of this particular 5 gigahertz radio. I'm going to say show signal strength for selected APs. So I'm going to show the signal strength for this 5 gig radio here. That's just a simple example. And then you can look at 1,000 other things like show me the packet loss that happened, or the delay times, or a summary of network issues, or spectrum analyzer data. It's just everything that you saw in the predictive view can also be shown based on actual real-world measurements. Whether you're doing a pre-deployment site survey or validating after the installation, it's all there. All can be tested. All can be measured. And of course, after this and after the plan, you can design, automatically generate awesome reports for your customer showing this is the installation. Make one click and it will create you a nice customized report. That's kind of scratching the surface of the tool, but still, giving you some idea on how things work. I think now might be a good idea to hand things over for a Q&A, given that we don't have a lot of time left. At this point already, we'd like to thank you for your time. Much appreciate you coming over and talking to us. And let's open the line for Q&A.
And just before we go to Q&A, I want to add one more important point. I did talk to Roger this morning, who's the VP of Sales for Ekahau, and he reaffirmed that for all certified and registered Ruckus partners, there's a 20% discount on Ekahau available directly through Ekahau. So make sure to reach out to your salespeople at Ekahau and take advantage of that if you're a registered Ruckus partner. Now, about those questions.
And the direct contact to our sales guy, he loves email, is roger@ekahau.com. So roger@ekahau.com, and tell him Jerry said hi, I need my Ruckus discount.
In the interest of keeping the time here, I believe the only question I see that was not covered was one about why not use wider channels that gives you higher speeds. What is wrong with limiting the TX power and using 40 to 80 megahertz for better speeds in cell?
Ooh, that's a good question. Actually, you know what? That's a nice, timely question as well. I was actually just listening to a podcast. I don't know if you're familiar with Clear to Send. If anybody isn't familiar with that one, definitely recommend subscribing to that podcast. but there was actually a really good podcast, I think the most recent one actually, with Devin as a guest speaker on the podcast that covered specifically about the inefficiencies of channel bonding. And, he talks about some of the negative side effects of channel bonding. So that might be a really good one to really, very technical deep dive into it. But I even, learned a lot, kind of listening to that. Devin does a great job kind of explaining, some of the technical inefficiencies there. It does increase data rates. So you'd think from like, making clients talk faster, that it gets them on and off the medium, but actually it can, channel bonding 40, 80 megahertz consumes so much of the spectrum, and the efficiencies that are gained from it are minimal in comparison to how much spectrum is being consumed by a single access point, that it can have some pretty big negative effects. There are obviously certain use cases like, home environments and, small offices, branch offices, things like that, where 40 and 80 megahertz definitely it makes sense. And there's, definitely more use cases for 40 than 80. But, yeah, great question. And definitely check out that latest Clear to Send podcast. Does a much better explanation on that than I can.
So as a summary, is it fair to say that if you have one or two APs, you're pretty safe, and no bad neighboring, bad interference from neighboring APs, you could, consider using 80 megahertz. But if you're doing, higher capacity, more APs, then definitely fall back to 40 or even 20 megahertz.
If you've got the spectrum available, might as well, utilize it. But there, from a channel reuse and things like that, it adds a lot of extra complexities that you have to, I guess, take into consideration. Certainly possible to use them depending on the environment, but more times than not, it's actually a bad idea to utilize wider channels.
Exactly. And I mean, the high speeds are tempting. But remember, it's the high speed of a single connection between an AP and a client. It doesn't mean high speed for all the APs and all the clients in the environment.
Yeah, and keep in mind, even if you're able to obtain higher data rates, that doesn't mean you're actually getting that throughput, right? Because of the overhead and everything else that has to be considered, and the neighboring access points and your own access points that will be contending for that airtime. You could actually be, making things from a throughput standpoint and a capacity standpoint, much worse.
Yeah, and there's always the pipe, how wide a pipe you have to the internet anyway.
Yeah.
Okay. Well, thank you, Jerry. Thank you, Thane. I want to thank everyone that joined us for this webinar. I hope everyone has a great day. Thank you.